All right, this is part of the homework check. This is worksheet 12. It says determine which functions are polynomial functions. We have two things going on in this chapter. Polynomials and rational functions, okay? A polynomial function means all of the exponents are positive whole numbers. So 6x squared minus 9x cubed plus 4x minus 6 equals 7. That's a polynomial equation, okay? All the exponents are, what degree is it?
3.
Degree 3. Everybody all right? A rational function, on the other hand, a rational is when you take one polynomial and you put it over another polynomial. Okay? That's called a rational function, and that's the weird graphs because they have asymptotes, right? But there are some other things going on here. Anybody see one that they think is not a polynomial? 15. Why is 15 not a polynomial? 1 over x. If I wrote that as an exponent power, it'd be x to the negative 1, and that's a no, right? So we just write no here. 14 you think is a no? What do you think about 14? Yes or no? Okay, it's a line. Is that a polynomial? What's the exponent power? The only thing that matters is the exponent power. The exponent power is positive 1. Is that okay? Yes. The coefficients, guys, the coefficients can be other things. For example, 19. What's going on 19? It's got a pi thrown in there, but is pi just a number? It's a coefficient. What's the exponent powers? 4 and 3. So is it okay? Okay, what about 18? What is the power for a square root? So x to the 1/2 times x to the 1/2 minus 1. If I distribute back here, I would get x minus the square root of x, or x to the 1 minus x to the 1/2. What do you think? All the exponent powers have to be positive whole numbers. So this is a no. 17? 17, what do you think? Nope. Kate says 20. What do you think about 20? That's a what? That's a rational expression or rational equation. Okay. Now, we have to go back real fast because all the yeses we were supposed to do what? If it's yes, state the degree. Okay. Let's start at the beginning. Is 11 yes or no?
Yes.
Yes with a what? 12? Yes with a 4. Be careful it wasn't in standard form. Oh, tricky, tricky. Number 13? What do you think here? Yeah, because can I just rewrite this as 1/2 minus 1/2 x squared if I divided them both by 2? That's just a parabola that opens down. That's a smooth curve. It's polynomial. Yes, degree 2. We forgot the degree on 4. What degree was that one? 14, sorry. Degree 1. 16? Yes, degree 2, somebody said. Is that right?
Yep.
Yep. Then we had no, 19?
4.
Okay. What about 21 and 22?
Yes.
They're both yes. They're just factored. Be careful. This one has an x with a squared outside there. And then in this parenthesis, it has an x squared. So that is a yes 4. We good? And what about this guy back here? X squared and an x back here that's cubed. So it's... All right. Awesome, guys. We just did half the homework, right?
I don't know if I'd call that half the homework.
We have a quiz on Friday. Is that your question? Okay. The quiz on Friday is all about graphing these guys. There are actually only 3 that you have to graph, but the rest of the questions are like find the vertical asymptotes, find the horizontal, find the end behavior, find blah, blah, blah. We'll talk more about the quiz tomorrow. Okay. Yes or no? Is this a polynomial function? Does anybody remember? Has to be a what? Smooth curve. No holes or discontinuities. No asymptotes. No sharp corners. So yes. Yes. No. No. Good job. Okay. Why not? Hole. Sharp turn. Okay. What else does it say for yes? Least degree it could have. This has to be at least degree 3 because why? Great. 2 turns or 3 zeros, right? No one else all day brought up turning points until I mentioned it. You guys are amazing. So degree 3. Okay. What about this one then? Why degree 4? Okay. Min, max, min makes 3. One more for the degree has to be 4. It's also got like multiplicity 2 going on here or something, right? An even multiplicity because it's doing a bounce thing. Yep, somebody mentioned this and I thought this was good. They said, well, if this slid down a little bit, it would cross 4 times, right? The x would cross, so it has to be at least degree 4. All right, good point. Everybody's okay. All right, 61. We're supposed to write an equation. Doesn't have to be a fancy equation. Tell me what this would look like. Why is there x? Okay, because it has a 0. So you could write x minus 0 if it made you feel better. But you can just write x, right? Then what's this factor? Okay. Hofbauer's happy with factored form. You don't have to FOIL it all out, get standard form. If you want to for a good time, you go right ahead.
If we want to make it look pretty.
I think it would be, let's see, this would be x squared minus 3x plus 2 times another x. I'm already lost. 3x squared plus 2x. I think that would be the standard form of that one, maybe. All right. Okay. What's going on different on 62? Okay, so what does that mean, that bounce?
Got a multiplicity of at least 2.
Multiplicity of 2 or 4, but it says to use least degree. It doesn't say, huh, you can give me a 4 on there if you want. You can give me a 100. All right, so somebody give me their final answer.
Y equals x
That's what I heard. Are we okay? All right, what do you... Yes, you can put 1 to the 1,000th power on the... Or x minus 1 to the 1,000th. It would increase the stretch and the flatness of the graph, but what do you notice about the pictures, guys, on 61 and 62? Is there any scale whatsoever on the y-axis? No. So we are just making up a generic equation. We have no idea. There's infinite answers that would work. 63 and 64, there's only one answer that works for each, because unless we talk about different forms, you know, factored form, standard form. But there's only one polynomial because it does give us a place here where it crosses the y. All right, so what we're going to do is we're going to ignore that for a minute and do what you did on 61. I'm going to call on somebody, okay? I'm going to call on Kirsten. Can you just write the equation with the factors? Y equals... Beautiful. Now, it has to... Right now, if I multiplied that out... I would get a, if I put in a 0 right now, what would I get out? 2? Positive 2. That's not right, right? It's not going to go through this point. We got to figure out a stretch that will make it go through this point. So we're going to do the good old find A or K. They use K instead of A. I don't care. Right here, we're going to plug in something. And what are we going to put in to find that K value? 0, negative 1. So for all the x's, we're going to put 0, and for all the y's, we're going to put negative 1. So it'll say negative 1 equals K times 0 plus 1 would be 1. 0 minus 1 would be negative 1. And 0 minus 2 would be negative 2. What does that all come out to be? 1 times negative 2 is 2. If we divide, we get K is negative 1/2. So our final answer is going to have a negative 1/2. And then all that other stuff, x plus 1, x minus 1, and x minus 2. How do you know that that's right or wrong? How could you check your answer? You could plug in another point, maybe. Could you graph it in your calculator and check that those 4 points that are dots on there will work? What about the end behavior? I'm too lazy to type it on my calculator. Do I at least know that the right end behavior is occurring? How do I know that? It's degree 3, and we came out with a negative. Is that what should be happening on the ends if it's a negative degree 3? Awesome. Yes.
I have like a really random math question, but we came up with cross country and I don't want to forget it. Just super fast. Like, is there such thing as an addition factorial? Like, do those exist?
Like addition of factorials, or
And like instead of like, you know, like
you could
factorial,
do
you
this.
multiply all the values.
Oh,
But is there one where you like add them all together?
add all the values?
Yeah.
Like 4 plus, it would just
like
be,
4 plus 3 plus 2.
yeah, it would just be summation notation.
Okay.
Yep.
was just curious.
I think that's what it would be. Okay, that was random. Okay,
Yes,
moving
I thought
on.
It was random. Okay.
What's going on? Can you guys do 64 now? Okay, what's going to happen here? Yeah, you got to remember there's a bounce there. That's going to be an x minus 1 squared, right? Etc. Can I just go on so we get to some of the tricky stuff before we run out of time? You guys can go back and finish 64? Okay, we're going to go really fast on this, like super fast. Because I want to get to the hardest part is that stuff at the bottom on the back. Is this an even or odd degree? How do you know? Both ends up, okay? Is it positive or negative? It is positive, again, because both ends are up. Okay, is the function even, odd, or neither? What does that have anything to do with? The symmetry. What kind of symmetry does this have? Y-axis symmetry. This is a line of symmetry down the middle, so it is even. Okay. Why do I know that x squared is a factor?
It bounces.
It has a bounce at 0, right? All right, what is the minimum degree of this polynomial? 1, 2, 3, 4, 5, 6, 7 maxes and mins means it's at least degree 8. Okay. This is supposed to be discovery activity, but in order to get to the other part, I'm going to go kind of fast here. You can pick anything. If I were to pick like -6, -4, and -2 as those zeros, okay, you could do -10, -5, -0.2, I don't care. But whatever you pick, if we said this is an even function, what has to happen on this side? Okay, 2, 4, and 6 are going to be those zeros. Got me? Are any of them have a multiplicity? 0 does, right? So there's an x squared there because it bounced it. I know my picture's a big hot mess. Okay, so I'll write the x squared first, or not. X squared. And then there's an x plus 6, an x plus 4, what else? 2, an x minus 2, an x minus 4, and an x minus 6. We had a big discussion. Can we just write, like...
Can I just, like, square them and then, like, put the minus?
How could you do that?
X squared minus 36. X squared
Yeah, you could FOIL those two together and write x squared minus 36, okay? But that's the only thing you can do. Somebody said, well, can't I just write x plus 6 quantity squared? No, because one is a plus and one is a minus. Okay. The whole 3 different equations, you could change so many things to write 3 different equations. You could change that x squared instead of to a squared to a degree 4 or 6 or 8, right? You could change the numbers because it didn't have a scale of any kind. But couldn't you also just decide to put some random stretch out here?
That'd be so easy.
Okay. You could put a 5. Could I put a negative 2 out here? No, because then it would go down if it had a negative leading coefficient, right? All right. If you wrote down one equation, I'm happy. Did you write down one?
I did.
Okay, we're moving on.
I'm crossing it out and I'll put more.
Do you remember how to factor cubes?
Yes, I do. Look right at my paper.
Do you have those on your... I wrote that on your paper for you to remind you how to factor cubes? All right. Oh! Oh, on my airliner. It's never given me that message before. Cool. All right. If it dies, I'll plug it in, but we're going to keep going. This number 42 right here. Okay. What's the domain? It doesn't ask that, but I want to talk about this. Okay. It wants the vertical asymptote. On your green sheet, that's number 3. It says set the denominator equal to 0. So it's x equals 6. Not does not equal. It's an equation of a line, and that line is at x equals 6. We okay? Then it says horizontal, oblique, holes. Are there any holes on this? How do you know? Common top and bottom, right? Okay. Then we look at the degree. The degree of the numerator is 1. The degree of the denominator is 1. They're called equal weight. And what do we do with equal weight? Y equals leading coefficient over leading coefficient, which would be y equals 3. So this does have a horizontal asymptote at y equals 3. All right. I want to talk about number 43. Yes. That's all I got to do. Number 3, we need to factor the top. How do you factor x cubed minus 8? X minus 2 plus 2x plus, okay? Remember, you square the first one and square the last one. That's where you get the x squared and the 4. And then the middle goes 1 of each, so 2 times an x. But the sign changes. If it was a cubic difference, the first one is minus, then plus plus. All right, how's the denominator factor? X minus 2, x minus 3. All right, so what do you notice right away? There's a hole. If we were doing the domain, would we cross this out and just use 3? No. X cannot equal 2 or 3. But is there a vertical asymptote at both 2 and 3? No. 1 is an asymptote and 1 is a hole. Which one is which? Okay, the hole is at x equals 2, which is actually not a line. It's a point, and I can talk about how to find that point. But if you just wrote at x equals 2 on your quiz, you'd be fine, okay? It's not the whole line. It's just at the x value of 2. The vertical asymptote is at x equals 3. Now we can actually drop that off once we've written down the hole and the domain. If I put a 2 in here, I get 12 over negative 1. Just take my word for it. So the hole is at 12 negative, or 2 negative 12. You don't have to do that part as long as you write at x equals 2. I'll be good. All right, this is the part that gets tricky. What was the original degree over the degree? Degree 3 over degree 2. That's top heavy, which means what?
Means we don't have to
means there is no... Oh. I thought you were bringing me a pass for somebody. I'm like, she gave me cheese. That'll be interesting on the video. Okay. Top heavy. What's the definition for top heavy? It's there is no horizontal asymptote, but you have to keep going and find the end behavior. The very bottom of the green sheet, it says to find the oblique or other end behavior, you have to divide and throw away the remainder. Are you with me? Okay. Guys, we still got 2 more minutes, so don't pack up. You would have to do, normally, if you looked at this long division, yes? But look what happened. When this divided off, can we now do synthetic?
Oh my god, I love life. Not really.
If it didn't have a hole, we'd be okay, but we couldn't do it. But it'd be 3, 1, 2, 4. You might have to do these on another sheet of paper. I don't know. If we bring down the 1, 3, 5, 8, 12, what happens now?
X plus
Where's the 15? Oh, that's 15,
It doesn't matter.
19. It goes away. Okay, thank you. What's the end behavior equation?
X plus 5.
Nope, that's not an equation. There we go. Y equals X plus 5. All right, we'll do a couple more examples off that if you need me to tomorrow, but take...